in this case. Alright, so I'm going to go back to equation number 1 and replace y with negative 9. So I have 2 times negative 9 plus 5z equals to negative 38. This gives us negative 18 plus 5z is negative 38. Solve for z. I need to cancel the negative 18 by adding it to both sides. So I add 18 to both sides. And we see it cancels here. So I'm left with 5z is negative 20 divided by 5. Then z equals to, what is that, negative 4. Alright, so we have another letter to solve for. And now we have to solve for x, and I would probably use equation 2, because x and z are the only letters in that equation. So if I use equation 2, then x minus 3 times negative 4 equals 24. And I hope you're noticing I use parentheses all the time when I plug numbers in. You'll avoid some sign errors probably if you do that. But the two negatives here multiply and cancel one another, so it ends up being 3 times 4, 12. X plus 12 equals 24. So some number plus 12 is 24. That number must be 12. Subtract 12 from both sides. Alright, so we have an answer. And it's 12, comma, negative 9, comma, negative 4. And so there's the point in space which satisfies this equation. This time I'll leave it to you to check it, but it's I've actually set up this problem to have integer answers, so I've already checked it. But I'll leave the check to you, just a matter of plugging numbers in. I just want to show you one other quick thing about this. In another video I talked about these linear equations representing planes in space. So what happens when we have 3 planes in space? Where do they intersect? And so, well, there's a lot of different things can happen here. But consider 2 planes. Here's a sheet of paper, here's another sheet of paper. And where do they cross? What do they make when they cross one another? And I don't have the best props here. I certainly don't have any animation, but try to imagine 2 sheets of paper held this way so that one is going to hit the other one. And they cross along an edge or along a line. Those 3 sheets of paper. And so on those 2 sheets of paper, then if I introduce a third plane, where does it intersect? And the 3 of them intersect at a point over here. You can also see this quite easily with any wall, corner of a wall. If you consider, say, the front wall, one plane, a side wall, another plane, the ceiling, a third plane, then where do those meet? They all meet in an upper corner. They meet in a single point. So that's why we tend to get a 3-dimensional representation of a point in 3-dimensional space, and it's because we're intersecting 3 planes together. If we had 4 variables and 4 equations, well, now it really gets abstract, because with 4 variables you're now working in a 4-dimensional space, and in a way we live in a 4-dimensional space if you consider length, width, and height as the 3 space dimensions, and time is our 4th dimension. Then we do live in a 4-dimensional space. We have a little restriction. We can't, although we can move around in the x, y, z space directions, we cannot move around in the time direction. Time just marches forward constantly. So, but as far as a geometric vision of a 4-dimensional space, I don't think anybody really has the capacity for imagining 4 dimensions. But if we had 4 variables, literally we would be intersecting 4 linear spaces, if that makes any sense. it would make a lot of sense to someone who lived in a four-dimensional world, who could, a geometric four-dimensional world. That would probably make sense. But you could define such things as linear spaces, and the intersection of four spaces is a single point. And of course it goes on to any number of dimensions you want. We can interpret this. So I think it's worthwhile to at least get a kind of a glimpse of an idea of what the geometry is behind what you're doing in algebra, whenever possible.